Hello Math 1040 students. The purpose of this video is to help you with the third part of the tuberculosis data project. For this part of the project, you are going to be taking the total TB incidence values that you found in part 1 of the project, and you are going to be conducting both a confidence interval test as well as a hypothesis test. First, for part A, you are going to report the 10 values of total TB incidence for each of the 10 countries. For example, if you go to the TB profile pages, at the top you found the total TB incidence. For example, for the country of Mali, we have a total TB incidence of 52. You're going to take all 10 of those values and report those neatly by creating a table. If you do not know how to create a table in Word, it's relatively simple. Open Word, and at the top you can select the Insert tab and choose to create a table of whatever size you want. For example, since I am taking my 10 countries and reporting their values, I might want a table with 10 rows and 2 columns. For right now, I can only make 8 rows and 2 columns, and I can put in whatever countries I want, for example, Mali, or the United States. And then I can input their values right next to that. So maybe 52 for Mali. I don't know what value it is for the United States, but let's say 68. And I can do that for all 10 countries. If I get to the end, maybe I put in Dominican Republic. And their value, which I do not know, I'll just say 12. I can hit the tab button to create more rows. I can also take all these values, paste them down appropriately, and I can use the top row as a label. For example, country and total TB incidence. Furthermore, you can even adjust this table further by putting your cursor near the middle of the table and dragging either to the left or to the right, and doing that for any vertical bar for the table. You can do it for horizontal ones as well, but you likely do not need to do that. This will make a nice and neat table. There's some other design things that you can do if you wish, but this should suffice for all 10 countries. You're going to make a table, try to present it nicely, and then you're also going to create an appropriate graph for this. Remember in section 4.1 we talked about at least 4 different types of graphs you can make. For example, a dot plot, a stem plot, a histogram, or a box plot. I would recommend that you either use a histogram or a box plot, both of which you can make in GeoGebra. I have gone into a spreadsheet and selected and made 10 random values, put them into a column here, and when I go to the top and select one variable analysis, I should be able to make a graph out of this. I would suggest you either choose a histogram or a box plot, but if you really feel the need to use a dot plot or a stem and leaf plot, that is okay. However, I still do ask that you do either histogram or box plot, as those are the better representations. You can then take a screenshot of this, and as the instructions state, you need to add a title of the graph and labels. A nice way to do that, for example, if you have this in Paint, you can do a few different things. You can export this as a picture, and you can save it to anywhere you want. For example, I'll just save this to my downloads. Yep, I'll replace that. And then I can open up Paint and I can open that image. I can do File, Open. The document that I just saved is in the downloads. Select that image, and now I have it open in Paint. In Paint, I can do quite a few things. I can select all of this, move it around as necessary, and I can even add titles as I wish. Choose a larger font, maybe. I can put a title up here. That didn't seem to work too well. I can put a title up here. There we go. And move that around as I need. Again, you would put in a more appropriate title for whatever this is supposed to represent. And you can also put axis labels on the sides as well. For example, the axis on the x-axis is supposed to represent total TB incidents. So I can move that down there. And the vertical axis is supposed to represent frequency. Once you have this adjusted in Paint, or you can also do this pretty well in Word as well if you'd like, you can select all of it. I use Control A to select it all, Control C to copy it, and then when I'm in Word, I can paste it, and I have my image. There are a few different ways to get this kind of solution or come up with a graph kind of like this with the titles. Again, you can also do this in Word by putting the picture in Word and then using possibly the draw option or maybe the insert option to put in labels above and below the graph. Keep in mind that your title should not just be title. Just come up with a good name for the graph of what it's supposed to represent. Doesn't need to be long, just something. That's what you're going to do for part 1 of the project, is create a graph. For part B, you're going to analyze the shape of the graph. For example, my graph that I had, my graph is extremely skewed, and specifically I would say that it's skewed to the right because I see the tail more to the right, away from the majority of the data that I have on the left. Now, based on it being skewed left, there are specific values I'm going to use for the center and variability. I will let you discover which two values you're supposed to report for whether it's skewed or whether it is symmetric. You should be able to see that in section 4.2. For any outliers, you're going to justify your answer by showing your work by calculating the upper and lower fences. There's a couple different ways you can show your work. The primary way that I would do, or I would suggest, is when you're in Word and you're trying to show how you calculated things, you can actually go into the Insert tab, and all the way to the end you'll find symbols, and you should also find equation over here. Yours may look a little bit different, but usually I see equation on the side. But if I click on symbols, I get an equation as an option. And what this will do is it'll make it very clean for when I'm trying to type in math. For example, when I'm trying to calculate the lower fence, or LF, that equals whatever quartile 1 is, which let's say that was, let's say it was 65, minus 1.5 times whatever the IQR is, which again I'll just make up a number and say it was 20. When I calculate that, 1.5 times 20 is 30. 65 minus 30 gives me 35. This shows nicely, mathematically, how you calculated your fences. This is a little bit better than not doing an equation, because if you don't do an equation format, it looks something like this. LF equals 65 minus 1.5 times 20 equals 35. It's a little bit harder to read, even if you put spaces in between. This is more optimized specifically for mathematics. So I would recommend that. For part D, you're going to check the conditions for using the normal model. There are 3 conditions that you need to check, and they are discussed in section 4.2. You need to make sure that we have randomness, which we should have. You need to make sure that your sample size is less than 5% of the population, and you need to make sure that you either know the population is normally distributed, in this case we would have to know the TB rates are normally distributed, or we would have to have a sample size that's at least 30 to satisfy the central limit theorem. I make a note here and say, for the purposes of this step only, consider the sample size n as the total cohort size of all 10 countries. For example, in Mali, the cohort size is 6,909. You use these values in the second part of the project for a couple countries. Go to all 10 countries that you have and add up the cohorts and consider that total amount to be the sample size. That should make the conditions a lot easier to verify. But again, only use that sample size as a sample size for part D. For part E and F, simply use n equals 10 for the number of countries. For E, by the way, you are going to compute and interpret a 95% confidence interval for the total TB incidence. In order to do that, when you are in GeoGebra, if I close a few things, when I'm in the probability calculator, I can go to statistics, and if I want to calculate a hypothesis test for a mean, I do t-estimate of a mean. I can put in my confidence level, the mean, the sample standard deviation, keep that in mind, sample standard deviation, and sample size. Your sample size for this one should be 10. Your mean and sample standard deviation would depend on your values. For example, for the set of data that I had, when I ran that and did one variable analysis and got my graph, I can also get statistics from that to find the mean of 152 and the sample standard deviation of 139.6. Those two values I can use as my mean and my standard deviation. So, let me input those in here. My mean of 152.5. Sample standard deviation of 139.6187. Try to use as many decimal places as you can. And I get my confidence interval is 52.6 to 252.3, or 4 if you round. That would be my confidence interval, and like with part 2, make sure you take a picture of this, so screenshot it and put it into your project accordingly. And keep in mind that you also need to interpret that interval. Think about how we make interpretation statements. It should start with, we are 95% confident. Lastly, for part F, you are going to calculate a hypothesis test using the claim that the global incidence rate of TB is 132. What you are then going to see is if the global incidence rate for TB is different than the reported value of 132. Because we just say different and don't intend to see if it's higher or lower, that means we're going to be doing a two-sided test. Keep in mind yet again, n is going to be 10 in this case. So when I go to GeoGebra, I will be using t-test of a mean, the second option there, for hypothesis tests. I'm testing against 132, and I'm doing a two-sided test. The mean and sample standard deviation should be the same as what I used in the previous step, as well as the sample size is still 10. In this case, I have a test statistic of 0.46 and a p-value of 0.65. Now it would depend on what alpha level you choose to see if you're going to reject or fail to reject, but in my circumstance with p-value of 0.65, that is going to fail to reject in all typical circumstances, as we typically use 0.05 or 0.10 or 0.01 for alpha, and in all those cases my p-value is far greater than alpha, so we're going to fail to reject. Keep in mind that you should state the rest of your conclusion in context, so don't just say that you fail to reject or that you reject. Make sure that you talk about what are you rejecting or what are you failing to reject. You reject because you have sufficient evidence that insert your conclusion here, or you fail to reject because you have insufficient evidence that insert your conclusion here. Put all that together into one project and you are done. Keep in mind, do not write down the instructions that I have for each of these steps. Just give me a 1 or 2 sentence explanation of what you're doing. Try to make sure the reader understands what you're working through. If you have any questions, feel free to comment on the announcement post that you see for this or contact me directly. I wish you the best of luck.